Today, I'll be going over three types of trigonometric equations that are quite common in appearing in your Year 11 Methods coursework. Our first type of equation is 2 cos 2x at 1 equals 0 in between the domain 0 to 180 degrees. Now, our first step when tackling this question is to see if we can alter our domain. Now, to alter our domain, what we want to look at is what is attached to the x inside the brackets. In this case, the x is attached to a 2 via multiplication, which means we have to times our lower end and our upper end of the domain by 2. So our new domain is going to be 0 to 360 degrees, and I'll explain to you shortly why this is important. Our second step is to isolate the cos 2x by itself. So what I get is 2 cos 2x. Now to remove the 1, I take 1. And then to remove the 2, I'm going to divide 2. So I get cos 2x equals negative a half. Our third step is to do exact values. So the exact values for negative a half that fit in between the domain, our new domain, 0 to 360, are going to be 120 degrees and 240 degrees. Our fourth and final step is to remove anything attached to the x, or anything in the bracket that is attached to the x. So what I get is x equals 60 degrees and 120 degrees. Note how these two answers, 60 and 120, fit into our original domain, 0 and 180. If we did not alter the domain to 0 to 360 to commence with, we would not have gotten 240 as an answer, and we would have missed out on 120 as one of our final answers. Now to go through the second type of equation. You may get something like this. Cos x take 1 in brackets and sin x add 1 in brackets equals 0 in between the domain 0 to 2 pi. What we want to do is we want to separate the brackets out. So each of these brackets is going to equal 0. So what I get is cos x take 1 equals 0 and sin x add 1 equals 0. I want to isolate to get it by itself, so I get cos x equals 1 and sin x equals negative 1. Now, our next step is to find the exact values. So for cos x equals 1, my exact values are going to be 0 and 2 pi. And for sin x equals negative 1, my exact values are going to be 3 pi on 2. I have nothing attached to the x, so I don't have to worry about our fourth and final step, and these are our answers. Now for the final type of trigonometric equation, I have something like this. Tan squared x add 2 tan x add 1 equals 0. Between the domain 0 to 360 degrees. What I want to do in this case is I want to make y tan x. If y is tan x, what is y squared going to be? Y squared is going to be tan squared x. I want to substitute y for tan squared x and tan x, so what I get is y squared add 2y add 1 equals 0. Note that I now have a quadratic equation and can factorize it to y add 1 equals 0. But what is y? Y equals tan x. So what I do is I just substitute tan x for y to get tan x add 1, tan x add 1 equals 0. As these are the same, I just have one equation, so tan x add 1 equals 0. I want to isolate it by itself, so I get tan x equals -1. And our next step is to find the exact values. And the exact values for tan x equals -1 that fit in this domain, 0 to 360, are 135 degrees and 315 degrees. And that's our answer for this question.